Alright, so now we're going to talk about the derivative of log, not natural log, but just log with any base. Some things to remember. We got the power rule, we got the chain rule. These are some things to always be considering when taking the derivative. Now, let's take a look at y equals log a to the x. And let's rewrite this in exponent form. If we rewrote this in exponent form, this would really be a to the y equals x. And just like before, what we can do now is we can actually take the natural log of both sides, which would give us the natural log of a, and instead of y as an exponent, we can write it out here as a being multiplied by the natural log of a, and this would just be the ln of x. Haven't taken the derivative yet. All I've done is rewrite it as an exponent here, and then take the natural log of both sides here. Okay, now I can take the derivative. So if I take the derivative of this guy, remember, this is just a coefficient. And so this is just going to be the natural log of a times dy. I'm doing this all implicitly. We talked a little bit about this before. And then the derivative of ln x, that would be 1 over x times dx. Right? Okay. So we're going to get the dy over dx all by itself. And we're going to divide both sides by the natural log of a, which is like multiplying this by 1 over the natural log of a. Okay, and so you get the dy over dx, or what would also be called y prime, is 1 over the natural log of a times x. And of course, if x was a more complicated function, it would be x prime. You'd have like the dx, or if this was a u, you'd have du out here. Okay, so that's actually the formula for the derivative of log a to the x. It's just 1 over ln a times the whatever's inside the log. Let's go to the next page. You'll see it. See, 1 over ln a x. They're just accounting for the x prime or the du or whatever it is that you may need here to finish off the derivative, chain rule thing. So if chain rule does apply, that's what these things are saying out here. Alright, so let's go ahead and do it. I know this is kind of written kind of funky. This should be over here. Y equals log 10 2x. So let's do this first part together. Y equals log base 3x, and we could just use this formula. And the x is just an x, so we don't need to really worry about chain rule. We're just going to do this part here. And so pretty easily we got that y prime equals 1 over the natural log of 3 times x. And that's really it. That's all there is to it. Why don't you try b on your own? It does have a little chain rule in it, so think about that as you're doing it. But give it a shot, and then just unpause the video when you're ready to check your work. Okay, so I did my u substitution. U equals 2x, therefore du is 2. So my new equation is y equals log base 10 of u. Therefore the derivative is 1 over the natural log of 10 times u on the bottom, and then times du out here. Well, plug it all back in. You got the natural log of 10, you got 2x for your u, and you got 2 for your du. Well, those 2's would cancel out, and so this would be your derivative. Let's go to the next page. Alright, see, now we're starting to get into some real interesting stuff here. This is the log base 10 of cosine of t. So let's give this guy a shot. This is definitely going to be some u substitution, because we're going to have some chain rule here. So let's let u equal the cosine of t, and therefore the du, the derivative of cosine, is negative sine t. So let's go ahead and rewrite this. That means that f of t, not the derivative yet, is log base 10 of u. Well, that's easy enough. We could take the derivative of that. It's just 1 over the natural log of 10 times u times du. And if you want to, you could just put the du on the top. That's where it goes. Okay, so let's plug it back in. The du is negative sine t. I'm just going to put that right on the top, over the natural log of 10. And the cosine is cosine of t. Okay. You could clean this up a little bit if you wanted to. If you think about it, you really have a sine t over cosine t. That's like a tangent t. So if you wanted to, you could write this as the negative tangent t over the natural log of 10. It's probably the simplest way to put it. Okay, let's go to the next one. I would, of course, encourage you to try this on your own, but I am going to just go ahead and work through it because it's a double chain rule, so I want you to see it. But, you know, give it a shot, pause the video, try it. So I would start off with the innermost part, which is the t squared minus 1. So I'm going to say that u equals t squared minus 1, and therefore the du is 2t. So the problem with this is, without taking the derivative, if I rewrite it, I still have a function inside of a function. And this would just be a u. Now, here's the thing though. I could rewrite this as an exponent. So I'm going to go ahead and do that. Let's just write it as log base 5 of u to the 1/2. And remember, your rules of logs say that if you have an exponent out here, you can make it a coefficient. So we can actually just say this is 1/2 log 5 of u. And remember, coefficients just stay coefficients, so this is going to be nice and easy. The derivative now is just going to be 1/2, and the derivative of log 5u is going to be 1 times the natural log of 5 times u times du. So if we plug in our u's and du's, we get du is simply 2t. On the bottom, again, I have 2 times the natural log of 5 times my u is really t squared minus 1. And, of course, we could cancel out these t's, and that's pretty much all we can do for that derivative. So, there we go. Let's go on to the next one. Alright, so this looks like we're going to have a quotient rule inside of a chain rule inside of a log. Or we could use our properties of logs. Properties of logs say that if you're dividing inside a log, it's just like multiplying. So let's try that. Let's say that this is really like saying y equals log base 10 of x squared minus 1 minus log base 10 of just x. This is going to be a lot easier to deal with. We still have a little chain rule here, so I'm still going to use some u substitution, but it's very manageable. So I'm going to say u equals x squared minus 1 and du equals 2x. Very manageable. So this is really like saying, well, log base 10 of u minus log base 10 of x. Okay, again, I think you could do it from here, so if you want to pause it, give it a try. Go ahead and do that. But I'm going to keep going. Here we go. So the derivative now, this would just be 1 over the natural log of 10 times u, and then times du. I'm just going to put that on the top, minus 1 over the natural log of 10 times x, and x is not a more complicated function, so I don't need to worry about the chain rule there. So let's go ahead and plug everything in. Du is really just a 2x over the natural log of 10. U is really a x squared minus 1 minus 1 over the natural log of 10 times x. Now I'm sure there's probably some way that you could get common denominators and clean this up a little bit. I'm very comfortable with this as an answer for now. If you want to play around with it, maybe you could find, you can multiply this side by x squared minus 1 over x squared minus 1 and this side by x over x and get some common denominators, but for now this is just fine. Alright, let's go to the next page. Okay, pretty simple one here, right? Just a pretty standard u substitution. Again, I want you to go ahead and try it on your own. Give it a shot, pause the video, come back when you're ready to check your work. Okay, so pretty straightforward here. I'm just going to do one little simple u substitution. Now I'm ready to take the derivative. It's 1 over the natural log of 10 u, then times du on the top, which is like saying 2 over the natural log of 10 times 2x, because that's what u is, And sure enough, these 2's cancel out, so this whole thing is just 1 over the natural log of 10 times x. Alright. Last one, I think that you guys can do this now. Remember your properties of logs. You can expand this. Go ahead and give this thing a shot, and then check back when you're ready to check your work. Alright, this one's pretty fun. First thing I did is expand it using my properties of logs. So this is really the top minus the bottom. Then I did u substitution, made u equal x squared, and therefore my du is 2x. So I substituted in and then just took the derivatives. Then I put my u's back in, and I noticed that I could cancel out an x, and so it simplified down to this. Not too bad. A couple things to think about, but remember, I can always use chain rule, and I can always use my properties of logs on problems like this. See you guys on the next video. Bye.